Okay, class, today we're going to be looking at some basic function vocabulary. A lot of this material has to deal with graphs as well as reading the graphs. So our first word that we're going to be looking at is increasing. Now, increasing, of course, means going up. So what we're going to be looking at is any part of a graph, just any part that is going up in some form or fashion. It doesn't matter how it's going up, as long as it's going up from left to right. We read a graph the same way we would read a sentence. We're going to read from left to right. Like if I was to read the function vocabulary at the top of the page, I would start over here with F, and I'd go over here to vocabulary. Now, the mathematical definition is the function is increasing on some interval when for any value A or B in the interval, if A is greater than B, then f of A is greater than f of B. We'll talk some more about what that specifically means when we get to class. Now, decreasing. Decreasing is going to be the exact opposite of increasing. As in, we know decreasing means something is going down. And so just like anything else in graphing, it means it's going down from left to right. So we need to make sure that's our common language. It's going to go down from left to right. Our mathematical definition is almost identical to increasing. So now what we have is f of x is decreasing on an interval when for any a and b in the interval, if a is greater than b, then f of a is less than f of b. Now our next two vocabulary words go together, and they both have to deal with increasing and decreasing. Our maximum. Now a maximum is just one very, very special point. And the only criteria for it to be a maximum is it is when the graph is going to switch from increasing to decreasing. So it was going up from left to right, and then it switches to falling from left to right. It's going down from left to right. So when we look, it's labeled as a relative high point. Can a graph have more than one maximum? The answer to that is yes. At any time where it switches from increasing to decreasing, a function will have a maximum. So our official mathematical definition, a function f of x reaches a maximum value at x is a if f of x is increasing when x is less than a and decreasing when x is greater than a. Then the maximum value is f of a. Now a minimum is going to be very, very similar to a maximum. All that's going to happen now is it's a relative low point. So what's going to happen is on the left side, on the left-hand side, we are going down. We are starting off decreasing, and then we're going to switch to increasing. And so this is going to be labeled as a relative low point. There can be many minimums in a function that, just the same as I said, there could be many maximums. Okay, think about a roller coaster. There's many peaks of the hills, and there's many valleys down at the bottom. Now, when we're looking at this, mathematically, a function f of x reaches a minimum value at x is a if the function is decreasing when x is less than a, and the function is increasing when x is greater than a, and the minimum value is f of a. Now, our next vocabulary word is going to be referenced a little bit more on the next page. What we're going to be looking at next is a special type of function behavior called asymptote. An asymptote can show up one of two ways. And what it's going to be able to describe is it's a boundary line. What I mean is this is a brick wall. The function cannot pass that boundary line. It can show up in one of two ways. It can show up going left to right. It can show up going up and down. And so when we look at our mathematical definition over here, it's any line that a function approaches for extreme values of either x or y. So there can be two types of asymptote behavior, and we will be studying these fairly soon in class. Okay, we're almost done. So the next two words that we're going to be looking at are another pair of vocabulary words that go together. Our first word is odd function. An odd function is, I'm not meaning it's strange, I'm talking about how the graph specifically looks. Now, when we're looking at this, this is how we're officially going to be talking about it. A function that has 180-degree rotational symmetry with respect to the origin. So we're going to be basically putting our finger on the origin, and we would be able to spin the page upside down completely. And the thing is that it would have to look the exact same. It would even appear to have the exact same coordinates if we're looking at it upside down. Now, our mathematical definition, a function is odd if f of negative x is equal to negative f of x. So that sounds kind of weird, so let's look at it. If I have some value here that's a comma b, and whatever the ordered pair is on the graph, then I'd have to have a second ordered pair over here where everything is just negative. And so that's all that an odd function means specifically, is that the points are symmetrical. There's a matching pair for every coordinate. An even function is another type of symmetry. This one is a lot like, almost like a butterfly, where it has been split right down the middle on the y-axis specifically. Okay, and this is our typical parabola. A parabola would be an even function. Now, it's any function that has reflectional symmetry with respect to the y-axis. If I'm looking at the right-hand side, it has a mirror image on the left-hand side. It looks the exact same almost. So when I look at the official definition, the definition we have is a function is even if f of negative x is equal to f of x. So when I'm looking at a coordinate here, it's very similar to odd, where if I had a comma b, now we might notice just based on the graph that the y value isn't going to change, and that's what the whole purpose of an even function is. If I switch to the negative value of x, the y value stays the same. It doesn't change. Now, our last vocabulary word that we're going to be looking at that's already on our page is what we call end behavior. Now, you might remember talking a little bit about end behavior when you were in Algebra 1, and your teacher specified that you had to put these little arrows on the edge of your page. End behavior is basically a mathematical discussion of what those arrows are doing. So when I'm looking at this, I'm going to be discussing whether the graph is going to point up, point down, or flatten out on either the left or right side of the page. We're not going to worry too much about we never worried about putting arrows in the middle of the page, so we're not going to start that now. We're always going to be looking at the very left and the very right hand side. Now, the official definition, as x values approach infinity, which would be on the right hand side, or negative infinity on the left hand side, the function values can approach a number, as we saw with the asymptote. If you want to look back at that, where those were hitting that boundary line, that would be an end behavior. Or it can increase, where we've got an up arrow, or it can decrease with our down arrow. So that's what we're going to be specifically talking about when we get to end behavior. Now, our next two words I would like for you to add to your page. The first word is what we call jump discontinuity. And basically what we're going to be looking at is a distance that we can measure. I can say that this went up so many points on the coordinate plane. But the whole thing is if we are right here, we can jump up to the next line. And it's typically given by what we call a piecewise function, but that's going to be something we'll define more in class later. Now, I know several of you are probably looking at this notation over here in this box and saying, what is that? Now, the first thing that we have here is what we call LIM. LIM stands for a word called limit. And this right here means from the left. So the limit, so what is the function doing as it comes from the left compared to what does the function do when it comes from the right? And what this whole mathematical definition is saying is when they're coming towards this point right here, they don't match up. They don't line up from the left to right. And there's a gap there. Now, our next type of discontinuity is what we call removable discontinuity. Removable discontinuity is a point that is undefined for the function, but there is a catch. It's not like the jump discontinuity. Jump discontinuity, there is no way I can put one point in this gap and fill it in. With a removable discontinuity, I can say, well, I filled it in. Okay? It's kind of like a pothole. We can fill in the gap. Now, typically, if we want to fill it in though, we want to make up a whole nother function that will be referenced as a piecewise function. It's basically to just fill in the gap. Now, the way we discuss it mathematically is as x goes to c, so as we get closer to this value right here from the left and the right, it doesn't match up with what's actually on the function right up here. Okay, so that's the end of our first set of vocabulary, and we will be looking to have a quiz over some of these concepts fairly soon. And so that's it for our first lesson, and I hope you enjoyed it. Thanks. Bye.